anybody has a question, just raise your hand or let me know, and I'll slow down and talk about something in more detail. But I want to get to the actual physical and technical safeguards, so that and I will slow down when we get to that section and try to be very, very clear about those, because we've already discussed the administrative safeguards. So we're going to talk about, just like I said, a brief overview of the security rule, and then the safeguards, and then we'll talk about some certain requirements or ideas for practices that outsource their EHR system. All right. So the privacy rule, everybody's familiar with. It's been around for a while. The security rule is really what we're talking about, the security rule portion of HIPAA, or we're not calling the omnibus rule. And the security rule really relates directly to electronic PHI, protected health information, patient records in electronic form that are in electronic systems like our electronic health record systems and so forth, practice management systems and that type of thing. So that's what the security rule is all about, and the objectives of the security rule are: we need to, as practices, we need to protect the confidentiality, integrity, and availability of the information in those systems, specifically the individually identifiable patient records, what we're calling EPHI, as you can see here. They want us to do that using 3 categories of controls or safeguards: administrative, physical, and technical. We already discussed administrative safeguards in a previous webinar, and now we're going to focus on physical and technical. Most of the safeguards in the rule are administrative, and we just barely got through it, as I recall, in the hour that we had. The physical and technical safeguards I combined because there's much fewer of them, and I'm pretty confident that we'll get through them all in the hour and still have some time for questions and answers. So we've got those 3 categories. We need to protect against reasonably anticipated threats and hazards to EPHI. That's basically as it's written in the security rule: protect against reasonably anticipated threats and hazards. Well, how do we know what are our reasonably anticipated threats and hazards? Well, that was we learned that by conducting our risk assessment, which was, I believe, the first Tech Hour webinar that we did 2-3 months ago, however long ago that was. So maybe we'll do another one of those again, because I think it's really, really important and helpful to understand the risk assessment process. So, and then protect against unpermitted uses and disclosures. Well, that's really how the security rule becomes sort of an enforcement of the privacy rule when it comes to electronic information. That's pretty much what that means. And then lastly, also specifically states that the rule wants us to ensure workforce compliance with the security rule, with the policies perhaps that we've implemented as administrative controls and physical and technical controls. Okie dokie. So the security rule is divided into, well, there are several standards under each of the categories, and then under each standard, and we're required to address or meet each standard. Under each of many of the standards, there are, again, implementation specifications that are slightly more detailed descriptions of what's required within the standard. And under the implementation specifications, some of them are required, that we just have to meet them as they're described, and then some are what they call addressable, which doesn't mean that we don't have to do anything about them. It just means that we don't necessarily have to implement them as they are specifically described in the rule, but we still have to meet the standard that it talks about. And if we're not going to implement an addressable implementation specification, we need to document why it's not necessary for us. And usually you do that by stating something in the risk assessment, or something that the risk assessment concluded that it's just not a risk to your practice, and that implementation specification just isn't going to help anyways. So. And the security rule applies to all of us, all covered entities, regardless of whether we're a 7,000-bed hospital or a single practitioner office. We still need to protect the electronic patient information that we collect from our patients. Understandable. All right. So I told you I'd keep it brief. I did. Now we're going to talk about physical and technical controls. We'll start off with physical controls. Physical controls are, they're called physical because they're protecting physical access to the asset or resource that we're protecting. So we're talking about things like locked doors and the way that we position our computer screens so that, for example, people in the waiting room can't see the screen, see patient information on maybe somebody that's registering or checking in a patient. We don't want anybody but that person to be able to see the screen. Very important is preventing theft, because the theft of laptops and tablets and thumb drives containing EPHI is actually right now one of the main, biggest, #1 causes of unauthorized disclosures. So policies also can be physical controls. Physical controls will include documented policies and procedures. Technical safeguards are, it's kind of fuzzy, the line between technical and physical, but the technical controls are really more generally seem to be hardware and software that we implement on systems like authentication systems or OTP tokens. That's one-time password tokens. It's a way to implement a stronger version of authenticating a user beyond just requiring a username and password. And by authenticating, I mean when you log into your system, log into the application, or log into the computer. That's authentication. We're going to talk about that more later. And there's sometimes, like it says here, tangible implementations of some of the administrative safeguards, or safeguards that we've implemented as a statement in a policy, like you will log off of your computer before you leave it unattended for, to go out for a smoke or whatever. All right, and we've talked already in great detail a month or so ago on administrative policies and administrative controls, which tend to be implemented in documented policies and procedures. Okay. The physical safeguards category has only 4 standards in it, and here they are. Facility access controls is talking about how we are controlling physical access to the rooms and buildings or equipment racks that contain the systems that house EPHI, whether it's the actual databases for our EHR system or maybe just PDF files that have been scanned in from physical patient records. But anything that has individually identifiable patient information is EPHI and falls under this and must be protected with these controls. The facility access controls, locked doors. In some cases, we may need to implement a surveillance system or some way of tracking who's gone in and out of the room, but the extent to which we need to implement these controls is generally determined by the risk assessment and the size of our practice. The second standard is called Workstation Use. I think most people will call it your acceptable use policy, because it's describing things like what your users are allowed to do with the laptops and tablets that we provide them, and internet access and the other resources that the practice has for getting its job done. Workstation security, kind of similar to workstation use, but much less of being a policy. It's more the actual controls that are in place, in many cases, to enforce what we've stated in our workstation use policy. And the fourth and final physical safeguard is device and media controls, talking about physical access to mainly portable devices like thumb drives and USB drives and that type of thing. So we're going to talk in a little more detail on each of these. Facility access control. This statement here in double quotes is exactly as the standard is written in the security rule. Implement policies and procedures to limit physical access to electronic information systems and the facility or facilities in which they are housed, while so that's the confidentiality and integrity part. And then this last part of the statement, while ensuring that properly authorized access is allowed, remember we also need to ensure availability to these systems for the appropriate people. So pretty well written objective statement there for this control. So facility is your offices, your sites, maybe remote data centers if you outsource some of your applications that process or transmit our EPHI. It also includes, if you remember from reading that quoted statement, the physical information systems themselves. So we need to have physical controls to secure access to them as well. For example, by locking equipment racks or locking monitors or access to the hard drives. So we don't want somebody to steal the hard drives out of our systems and walk away with our EPHI. That's physical access, and physical safeguards control that. Some examples of controls you might implement: simply having signs that depict what areas are restricted areas or authorized access only, that type of thing. Locking doors. I mean, that ideally, if we can house our systems in a separate room, lock the doors and give only authorized people keys to those rooms, and then that's ideal. I know that we can't always do that. Sometimes the systems are implemented also where physical records are stored or some kind of storage room and other people need access, but maybe we can put those systems in a locked rack, keep that lock racked, so that rack locked rather, so that cleaning staff and that type of thing, that those type of people that are not necessarily authorized for access to those systems can't get access. Badge access systems commonly implemented in larger practices or hospitals. One of the great things about a badge access system, that's where you kind of just you get a badge and you can wave it in front of the door, and that unlocks the door for you. But the other great thing that does is it automatically logs access to those systems. So, visitor control. Maybe you have your visitors may need to sign in, and you keep those logs so you know who was in the building and had access to what on what date and time, in case you need to do some type of investigation or whatever. And you can identify, have the visitors wear some type of sticker or something that indicates that they are a visitor, and your other employees know that they're there and that they're probably not authorized to see a lot of stuff. So hopefully people will keep their eyes open and keep an eye on those folks. Alarm systems, motion sensors generally come into play, after the office is closed to protect physical access to our assets during non-business hours. Surveillance systems, another way to, if you had to do an investigation later to figure out what went on, that may be overkill for some smaller practices, but it's still an example of a physical facility access control. A layered defense is always best, whether we're talking about administrative controls or physical or technical controls. Just for security in general, let's not rely on one thing. Locked doors, combined with a motion detector, some type of intruder alarm, is an example that I think everyone can relate to, of a layered defense, not relying on a single control. If somebody gets through the locked door, hopefully they're going to trigger an alarm, and one control has backed up the other, and the bad guy still gets busted, hopefully. There are some implementation specifications under facility access controls, and here they are, the 4 of them. Contingency operations. So what if our facility becomes unavailable? Some terrible thing happens in our facility, a flood, who knows, and usually it's some type of natural cause. So contingency operations would be a plan that describes how we can continue the services that we want to provide if our facility becomes unavailable. Again, your risk assessment will determine how important that would be. Facility security plan. If we have a fairly complex facility access controls or facility where we have certain areas that are restricted, certain areas that are unrestricted, so that we can implement different layers of or different levels of controls for the different areas, we need to have a plan that describes which areas are which areas are more secure, and what controls are implemented there, and so forth. So that would be our facility security plan. Access control and validation procedures. Well, the access controls are the things like the locked doors that we mentioned. And validation procedures would be ways that we can make sure that only authorized people are granted access to these areas that have the, for example, databases and so forth. The badge access system is a great way of validating, because you would only give authorized people those badges, and when they use the badge, you know, hopefully it was that authorized person that got that access. Maintenance records are ways of making sure that the controls are properly maintained and having records of who is doing the maintenance and so forth. Generally considered overkill for some smaller practices. I guess you could kind of say that all of these would be overkill for many very smaller practices, but we still need to have facility access control. So we still need to basically secure our servers somehow. Hopefully we at least have them in a locked room, and we can control who has the keys to those rooms. Another important thing I think to keep in mind when we're talking about facility access controls, and we mentioned how the importance of a layered approach to defenses. The facility access controls are effective when you're protecting assets that are located within the facility. If your employees are taking laptops that have EPHI home, well, you know, you just removed that layer of defense, and now you're going to be dependent on something else. You know, in that case, perhaps your workstation use policy. Also, backup tapes. A good backup program, and we talked about backups in under administrative safeguards. A good backup program would include taking copies of your backups off-site, so that, you know, again, if you have some type of disaster in your facility, you don't want that disaster to wipe out your backup tapes, because what good was it doing your backups if you can't use the tapes? If the tapes or whatever you use for backups get wiped out as well. But when you take them off-site, that also is a little bit of a risk. So we're going to talk about device and media controls, one of the other standards, physical safeguards, very soon. So that was facility access control. Workstation use policy, again, I think of it as an acceptable use policy, and how you describe to your users what they're permitted and not permitted to do with the resources that you grant them access to, the phones that you give them, smartphones, tablets, laptops, that type of thing, but also the access that they get to the internet that you provide them, what they're allowed to do with that, because those are all risks, and they're all vectors or ways that people can expose EPHI in a way that they are not necessarily supposed to. So we need to control all of that. It sounds like an administrative safeguard, I know, but really this particular workstation use policy, the purpose of it is to describe or protect physical access to things like workstations. And one of the things that, like I mentioned earlier, you know, theft of laptops and tablets is really a major cause right now of unauthorized disclosures. So we need to do a good job of preventing theft of our workstations. Workstation security is you know, another physical safeguard standard. It kind of relates to workstation use policy in that the workstation security controls are controls that might enforce what we've stated in our policies. They are controls to prevent unauthorized physical access to workstations or thumb drives that might have EPHI, or CDs or DVDs, or anything that can house electronic patient information. So our workstation use policy should address, at a minimum, these things here. Who owns, you know, the laptops and internet access are owned by, you know, ABC practice. Were implemented so that our employees can do their jobs, and you might want to state to what degree you're going to allow your users to use those resources for personal or non-business related issues. Okay. Right to monitor means you need to come right out and let your users know that activity that they do on the network or on the practice's computers may be monitored. Your users should not assume that what they are doing is private. Okay, so you need to let them know that you have the right to monitor what's going on in order to protect the practice. Acceptable use of computing equipment. One of the biggest is, are you going to allow your users to take laptops home? Because that's clearly taking a bigger risk, and we need to figure out how we're going to secure those laptops when facility access controls are not protecting physical access to those devices anymore. Acceptable use of internet and the email system, very important. You need to decide if you're going to allow users to even send ePHI at all via email. Usually it's no, because, well, it's illegal really to send unencrypted ePHI via email. What people do on the internet is representative of your organization. You want people to use the internet in a professional manner and so forth. So, and there are plenty of examples out on the internet of good acceptable use policies, but an acceptable use policy is not a policy that I would skip in my information program. I really think it's pretty important to have that, and for all of your users to be trained on it and understand what your acceptable use policy is. Leaving workstations unattended is also a risk, obviously. This may be the policy where you come right out and say, don't leave your workstations unattended. Log out and then go have your lunch or whatever and come back and log back in. We're going to talk about some examples pretty soon under Workstation Security, some examples of controls that might help enforce this. One of my favorites is locking screensavers, so we'll talk about that in a bit. Bring your own device. We mentioned, are you going to allow users to take their laptops home? Well, are you going to allow your users to bring their own laptops in and connect them to your network? Are you going to allow your users to allow their smartphones, their iPhones and Droids and so forth, to connect to your wireless LAN? Okay, because that's a risk that you need to understand and have controls for as well. Shoulder surfing, users need to be aware of their surroundings when they have ePHI on the screen. We talked about screen positioning. We'll talk about privacy screens as examples of, again, workstation security controls. But as far as the policy goes, you want your users to be aware of who's around them when they have sensitive information on their screen. Is there somebody changing the light bulb in their office? Make sure that person is looking at your screen, or what we generally call shoulder surfing. So that brings us to our first audience participation poll question. So as I was writing about and talking about the risk of allowing your users to bring tablets and laptops and stuff home, I started to wonder, well, how many people, what percentage of our audience today allows users to take tablets home? So Tim, take it away.
Yep, so here's our poll question. It's just simply, are users allowed in your practice to take laptops or tablets home? The question is yes, disks are encrypted. Yes, disks are not encrypted, but there's no ePHI. Yes, but disks are not encrypted, or no, you don't allow them to take home. For those of you, while you're answering that question, so when we talk about encrypted disks, this is a process that basically renders your hard drive useless if your laptop's stolen, if you don't have that password. When you boot your laptop up, it prompts you for a password, not your login password, but an actual password to access the hard disk. And if you don't have it, you can't get into the hard drive. You can't get into the computer. And even if you were to take that hard drive out of the computer and plug it into a different computer, like a tech guy might if you stole a laptop or took a laptop, that encryption would still render that laptop useless, because in order to access it, or that hard drive useless, because you still have to have that password to be able to get in. So when we
Yes,
talk about,
imagine how frustrating that is to the thief, Tim, that
yeah,
goes through all the trouble of stealing the laptop and you can't even boot the thing up. And that's
yep.
a great control that we're going to talk about in a minute.
So that's what we're talking about. We're talking about encryption. So if we can go ahead and answer the question, and then we'll move on with our presentation. So here we go. It looks like we have our answers, and a good 2/3 of our people are encrypted, which is great. And there's a third of our people that do not allow people to take their laptops at home, which is also a good control. So Chris, go ahead and take it back from there.
Certainly. So taking the laptops and tablets home is one thing, but maybe we shouldn't have said home. Maybe we should have said off-site. I think oftentimes practitioners will take their tablets and so forth to a hospital or wherever else they may be working, and there's certainly good reasons why they would need to do that. But you know, the risks are still there. The risk of that tablet or laptop being stolen still exists, and I highly recommend whole disk encryption for some of the reasons that Tim just mentioned. So, and that's an example of a workstation security control, hard disk encryption. We mentioned pre-boot authentication, and I think Tim kind of mentioned that as well. Basically, what that means is that when the entire hard disk of the laptop is encrypted, you need some way, some type of key, if you will, a decryption key to decrypt the hard drive just to even get it to boot up into probably Windows. And that's what the pre-boot authentication screen is. So it's not a Windows login screen. It's a login screen that's presented by whatever tool you're using to encrypt that hard drive. And it's a great control because, like we sort of joked about a minute ago, it basically makes the laptop almost useless to whoever stole it. You know, the most they can do is take the hard drive out and throw it away. Now they got to buy a new hard drive. Otherwise, the laptop is really useless. But the advantage to the practice is that you don't have to worry about unauthorized disclosure, and you don't have to worry, even legally, about the breach notification rule that maybe you've heard about and maybe has frightened you. If there is an unauthorized disclosure that you find out about, you need to notify your patients that were affected. You may need to notify somebody in the OCR, and maybe even perhaps the media. So the breach notification is a huge thing, but one thing that it does say is that it only applies to unprotected EPHI. So if your hard drive in the laptop that was stolen was encrypted, you don't need to worry about notifications. So that's pretty important. Automatic log off or locking screensaver is a great workstation security control to prevent incidental access, or maybe even intentional access to a workstation that somebody has walked away from but failed to log off, as hopefully your workstation use policy requires. So here's a control that will take over. I like the locking screensaver. You may have a hard time enforcing automatic log off. Practitioners kind of hate that because it sometimes takes a little while to get logged back in, especially if you access your systems through Citrix. It tends to have a fairly long log-on time, and practitioners are maybe in a hurry to get logged in. So a locking screensaver that's implemented at the workstation itself is much quicker. It just requires that your Windows authentication, again, your Windows username and password, to unlock, and generally occurs very quickly and puts the user right back at the screen they were when they broke your policy and walked away and left their workstation unattended. Privacy screens are things that you can put on your computer monitors, and it reduces the angle to which the screen is visible. So you kind of need to be looking right at the screen almost directly, and it makes it so that people that are to the left or right of you can't read the information on the screen. So in certain instances, depending on the location of the screens, those may be a type of security control that you might want to consider. Remote wipe that's an interesting one. I always get a kick out of this one. There actually are certain chips in many laptops that are sold today. I think it's called a TPC chip or something like that, a security device that would allow the contents of the hard drive to be erased remotely if the laptop were ever stolen. So if you're personally, I still recommend a whole disk encryption, and then you don't really need to worry about something like that. But the remote wipe is another example of a workstation security control. Another important one is not granting your users administrative rights to the workstations. That can be a tough one because I have seen many cases where the software that your users need to use actually requires admin rights. That's, in my opinion, poorly written software, but it does exist. And when you have to give all of your users administrative rights to the desktops, you're in many cases also giving them the ability to do things like disable the antivirus software, which, yeah, that might speed up the computer a little bit, but only until the viruses start to come in, and then they're going to slow right back down again. Also allows your users to install all types of software like iTunes is something that I find a lot, which also will slow down your computer, by the way, which is probably not needed for them to do their job. So ideally, you want to make sure they're not administrators if that's at all possible. Which brings us to our fourth and final standard under physical safeguards, device and media controls. Here again, I've included in double quotes the exact verbiage from the security rule, the way it's written, policies and procedures that govern the receipt and removal of hardware and electronic media that contain EPHI into and out of a facility and within the facility. Sounds kind of weird or like overkill, but really, when you've got this little image here is of what many people call a thumb drive or a flash drive, really can be dangerous if you're saving EPHI to those because they're so easy to conceal or steal or lose, and all of those things are very bad if the device contained EPHI. So we need to have controls to address that issue, and that's what this standard does. Mainly, the main portion of this that we're going to talk about are the reuse of these media devices and the disposal of these media devices. And we've got 4 implementation specifications to go over for this standard. So some examples of devices that these apply to: CDs and DVDs, like we said, thumb drives, portable USB drives, anything that can store electronic files and be portable. These underlined words here: disposal, media reuse, accountability, data backup and storage. These are the 4 implementation specifications. Disposal is a big one. Basically, what we're saying here is that you can't just throw away a thumb drive or even a CD or DVD that has EPHI on it. Not only that, just deleting the files off of that device is also not good enough, because when you delete something from a folder on your computer or from a folder on your flash drive, it really isn't removing the file from the flash drive. It's only removing the pointer to it. And I'm not even talking about the Windows recycle bin. Maybe you're familiar with the recycle bin, where you can actually go in and undelete something that you perhaps mistakenly deleted. That's another thing to consider, but that's not what I'm talking about. Even without that, even without the recycle bin, or if you remove everything in your recycle bin, it's still not removing the information of that file from the device or from that hard drive or from that flash drive. It's still there until the location on the device where that file was gets overwritten by something else. So proper disposal would be using some type of tool, and that there are tools out there that do this, that overwrite locations where files have been deleted multiple times, and to be legal, it has to be overwritten multiple times, that the file that was there cannot be recovered. Okay, there are entire books that have been been written about that, but there are even I've seen free tools out there that will overwrite those locations, but they'll take a while depending on the size of the storage device. Can take a while to run. So generally, what I see people doing, especially with hard drives, is instead of trying to erase them, they destroy the physical device literally with a sledgehammer or a drill or um, send it out to a company like Iron Mountain that does that, for a living, and they'll give you a COD or certificate of destruction to prove so that you have proof that the device was destroyed and that information can't be recovered. Reuse of media devices kind of similar. You can't take a device that was used, maybe on an imaging system and has image files on it that includes patient information, and then go and use that for, in the billing area or in engineering or some other area. You need to make sure that the previous information was completely removed, again, through something like overwriting it, or just don't reuse the device. Get something new. In many cases, that's just easier. And those two implementation specifications are required. And they, again, really are important. You also have the opportunity or option of just not using portable media devices. If you can get away with not storing EPHI on these devices, then even better. The two addressable ones are accountability. We need to track the movement of these devices. Handoffs from one department to another or from one user to another should be documented. You can kind of create sort of an auditable paper trail of where the device went. So if it did get lost, it makes it much easier for you to find out where it may have gotten lost or who was responsible for it, and maybe even be able to get the device back. The data backup and storage kind of addresses we talked about confidentiality and integrity and availability, the objectives of the security rule. This one kind of talks about the availability. We want to make sure that that EPHI is available to authorized people, so they are suggesting that we back up the information that's on a system before we relocate a system. Again, up to each individual practice in their risk assessment to determine whether that's appropriate for or not for your practice. And that is it for physical safeguards. There are a few technical safeguards that we're going to talk about now. Technology policies, procedures that control access to EPHI. We've got 5 standards here under technical safeguards. Access controls. Sure, I mean that's a biggie. That's really what this is all about, is making sure that authorized people have access to our systems and unauthorized people don't. We're going to talk about the 4 implementation specifications for there. Audit controls, well, not only do we need to control who has access, but we need to have records of who accessed what that we can refer back to later. Again, a paper trail, auditable paper trail. Integrity, we'll talk about that when we get to it, but that's basically controls to ensure that we can trust the information, that it hasn't been changed or altered in an unauthorized way. Person or entity authentication, in my opinion, really falls under access controls, but the way the rule was written, they made it a separate technical safeguard sort of category. So we'll talk about that one, but you'll see how it really ties directly into access controls. Transmission security is technical controls to protect the information that we send to someone else down the wire. What happens to it while it's on the wire? How do we make sure that it's only going to the person that we want it to go to, and that it can't be captured by an unauthorized person and actually read? So access controls. Oftentimes, if we host our EHR system by somewhere else, then there will be a login screen that is hopefully controls access to that application, and that would be implemented by the provider or whoever we're outsourcing that application with. There are many places where authentication as an access control are implemented. You probably need to provide a username and password when you first turn on your computer. That's probably a Windows authentication. That's one of the access controls. Then you may need to log in again to get to the application, and again, that login screen may be controlled by the provider, but it's still an important access control that makes sure that only authorized users can get access to that information in that application. So we as the practice still have to control access to the workstations that our provider has allowed access to. So this rule isn't something that we can just skip over if we host our EHR systems. So, and the access control standard has 4 implementation specifications that we're going to talk about. The first one being unique user identification. Sure, so for authentication, we're providing a username and password in many cases. Well, that's only going to be effective if we comply with this unique user identification requirements so that we have accountability. I've seen in many practices, maybe you guys have recognized usernames like Scanner or Scanner1 and Scanner2 or User1. We need to avoid that. Those are clearly shared user accounts, and we really should not be granting access to EPHI using shared user accounts. So those are ones that we should avoid. Each user should have their own credentials, their own username for the system that only they can use. They don't share their password with anyone else. So that's unique user identification. Emergency access procedures. We don't want our security controls to prohibit access to information that we may need during an emergency to perhaps save a patient's life. So this is something that I think is more applicable in a hospital environment or where there's an emergency room involved, so we're not going to spend any more time on that one. Automatic log-off we kind of talked about already. A way to secure unintended workstations where the user has quote-unquote forgotten to log off, as again required by hopefully your security or your workstation use policy or acceptable use policy. Locking screensaver is another example, but the locking screensaver will only qualify as a control if it requires a username and password to unlock it. Encryption and decryption we spoke about also. With regards to protecting physical access, if the laptop is stolen, if you had implemented whole disk encryption, well, it still kind of stinks that the laptop was stolen, but it would stink a whole lot more if there was EPHI on there that wasn't encrypted. Okay. And again, the #1 cause of unauthorized disclosures is these unencrypted stolen devices with unprotected EPHI on them. So the audit controls, these are the last technical safeguard standards here. Audit controls, we need to be able to have a record of who accessed what and when. So that basically means enabling the logging functionality in your application or in your system. Maybe it's enabled by default, maybe it isn't. Don't assume that it is enabled by default, and make sure that you know how to get access to those logs and you know how to read them. Actually going to show you an example. Let's see here. Of a patient access log here. This is from Centricity, from CPS. This is all made up from a demo database, but it's I just wanted to show it to you. This shows the date and time that this username, in this case admin demo, and what they did, they viewed patient data in the registration section of Centricity for the patient with this patient ID and this name, and there you go. If there's any question about maybe unauthorized change or disclosure of that record, you want to find who logged in as who is admin demo or who logged in as admin demo and talk to that person. So here's your paper trail. So just a quick example of that. Integrity. Integrity is, it's one of the three things that we need to protect overall with our patient records because of the security rule. We want to make sure that we can trust the information, that it hasn't been altered or modified or destroyed. But we're talking about technical safeguards in this case. So examples of technical safeguards that protect integrity are, well, technical. They're things like um, disks that are configured in a RAID array, which basically means that the information is spread across multiple physical hard disks in such a way that if one of the disks failed, and if you know anything about computers, you know that disks do fail, that the information will continue to be accessible and trustable um, because of the way that the RAID system copies the data across the multiple disks. ECC RAM, when we talk about RAM, we're talking about the memory, not the hard disk, but the memory where things run in your computer system. ECC RAM is RAM that has the ability to automatically correct for errors and check that, again, the integrity of what's in the memory is correct. So we try to implement servers, or we should try to implement servers that have at least these things to protect the integrity of the information that we store on those servers. Person or entity authentication. This is the standard that I was talking about that really, in my opinion, falls under access controls. But this is specifically the requirement to make sure that in order to access EPHI, a user would need to provide authentication, and usually that's a username and password, but not always. Sometimes a username and password isn't adequate way to authenticate, and we may need to go beyond that and require some multi-factor authentication. And an example of where you may need to do that is if you're going to allow what we call anytime, anywhere access to your system. So if users can go outside of the facility access controls of your network and just connect anywhere on the internet and log into your EHR system, your EMR system, then you really should consider whether username and password authentication alone is adequate to protect access. Or maybe you need to provide one-time password tokens or some other form of authentication that requires more than just a username and a password that somebody could guess. So, transmission security is, again, we're not allowed to send EPHI over a public network like the internet if it's unencrypted. So ways that we encrypt that information, the most common way is through VPN tunnels, like an IPsec VPN tunnel, virtual private network. One of the things that a VPN tunnel does is it encrypts everything that's going through it. That also addresses, by the way, integrity, because if you've got fully implementing IPsec, it's actually authenticating to check the integrity of the information to make sure that it arrives the same way that it was sent. So VPN tunnels, highly recommended if you need to send sensitive information over to another office or another provider across the internet. And here's our last poll question. Jim? Tim, you still there?
Yep, sorry about that. I'm here. Does your practice allow anytime, anywhere access to your EHR from the internet? So the question is, yes, you do, and you require us to username and password to get in. Or yes, you require two-factor authentication using some sort of hardware token. Or yes, it requires other than username and password or a hardware token, or no, we don't allow access at all. So when we talk about these hardware tokens, what we're looking at is those little, sometimes they're from RSA or VeriSign. Hospitals give them out a lot, and they're just, usually it's a random string of numbers that change on a rotating basis, and you have to enter your username, your password, plus the current random string of numbers. That is your two-factor authentication with a hardware token. So if we can have everybody again answer the poll question, we'll see what the results are here. So here we go. It looks like the results are 50% use just username of Windows authentication to be able to get in, and 50% have a third-party token. So that's pretty good. It's a good mix. I'm glad that we don't see access. What's real important that we see here is that there is an anytime, anywhere access to EHR from the internet, and that we're securing those connections. So, Chris, why don't you take those over?
Sure, yeah. So if you're depending on just the username and password to authenticate, and again you're outside of the physical or facility access controls or the physical boundaries of your network, a password policy becomes even more important. You really need to make sure that your users aren't selecting passwords that can be guessed. So password policy, hugely important if you're going to trust just username and password for access to your organization. So outsourcing EHR, many practices don't host their electronic health record system in-house. They send it out to somebody else to do that. And when that's done, yeah, the ASP, the provider that you're hosting with, is going to implement many of the controls that we just talked about, but as far as being responsible from a legal perspective, the practice is still the owner of that EPHI, even though it's hosted somewhere else, and is still responsible for addressing and having policies and procedures, and in many cases the controls, like controls for physical access to the workstations that have access to the hosted information. The practice is absolutely still responsible for all of that stuff, so please don't assume that that just because you're hosting your EHR system that you don't need to worry about those controls. You do. So I recommend having some type of a document or a standards document or something, contract or agreement with the hosting company that describes, your requirements for protecting your EPHI that you own, and what they're going to implement as far as controls and what you're going to implement, and get that from them in writing. Okay, you will have a business associate agreement with them anyway. You're required to do that now. You could implement that verbiage in that document as well. Another thing to consider, let me just make sure I didn't miss a slide, and I did. When you're outsourcing your EHR, you're probably accessing that system through your internet connection. So now your internet connection is critical. So you need to consider whether one single connection is adequate or not. If that fails, your internet connection on your end fails, and you can't get access to the provider or to the system anymore, how much of an impact is that on your organization? Go through that drill, even if it's just in your head, and determine how much downtime is acceptable, and decide whether you need to implement something to prevent that or make it less likely from happening, or some kind of alternate connection to the internet. And if you're going to consider a second connection, make sure that you're not getting just another T1 circuit from Verizon, which is the same as what you had before, because those are probably going to come in on the same physical connection, and a backhoe attack or somebody hitting a